Since their inception, modern airplanes have undergone a battery of rigorous testing to ensure their maximum level of safety. The stresses that airplane manufacturers subject them to are tremendous. Hello, and welcome back to INO 6, where we discuss everything about innovation, construction, and future civilization. In today's video, we'll discuss what does it take to establish a new aircraft model. So, without wasting time, let's get started. Updates to the 737 MAX's flight control software and pilot training are just two areas where Boeing is concentrating its efforts as it works on a repair to get the grounded aircraft back in the air. Dennis Muhlenberg, the CEO of Boeing, announced on April 17th that the business has finished its own airborne validations of the upgraded software, the last step before submitting the finished product for official certification to the Federal Aviation Administration. A new aircraft continues to undergo flight testing well after it's certified as manufacturers make changes or improvements to the design. The 737 MAX updates are unusual because of the crisis surrounding the aircraft following the twin crashes of Lion Air Flight 610 and Ethiopian Airlines Flight 302 in October. Additionally, they must pass a battery of tests before entering commercial operation, starting even before they take to the air, to make sure they meet or exceed all safety requirements. But what exactly is needed to put a new airplane into service? A new commercial airliner's rollout represents the visible result of years of labor by the aircraft's engineers, designers, and production team. The Airbus A350, Bombardier C Series, Comac C919, Embraer E190-E2, Mitsubishi MRJ, Irkut MC-21, and most recently the Boeing 777X are just a few examples of the many aircraft types that have lately rolled out of the factory. While a rollout marks an important turning point in an aircraft's development from concept to customer, it also marks a festive break in the rigorous testing of a new model and the beginning of the most noticeable stage of design testing, flight testing. The first few aircraft to leave the production line are intended for the flight test and certification campaign. They may never be delivered to airline clients, get wrung out in the air, or wind up on an exhibit in a museum. The flight test fleet for the Boeing 787 consisted of 6 primary aircraft, compared to 7 for the Bombardier C Series. No one will ever use an airline. This fleet of airplanes logs countless hours in the air while testing a variety of tasks known as test points. The 5 A350 test aircraft logged 2,600 hours of flight time over a 14-month period to receive certification from the US FAA and EASA in 2014. The 481-page, very thorough FAA Aviation Circular AC-25-7D Flight Test Guide for Certification of Transport Category Airplanes is the current standard for the operational and safe design of new aircraft. With the regulator, every aspect of the jet's certification is discussed to decide how the maker will prove the design complies with the most recent rules. That may involve doing engineering analysis, laboratory tests, ground assessments, and even whole aerial trials. But before the first aircraft takes off, its pilots will have spent countless hours controlling it in a remarkably lifelike full-motion flight simulator. Based on a thorough technical and aerodynamic examination of the design, the projected flying characteristics of the new plane will have been put into the simulator. Initially, the sim may or may not accurately reflects how the actual plane ultimately flies. However, the simulator is updated when the maker analyzes the information from real flights. Any jet must undergo a demanding series of violent structural tests before it can take its first flight. The static test rig is used to perform structural testing on an airframe, including overpressurizing the fuselage and bending the wings to make sure they fulfill strength requirements. The ultimate wing load test is the most dramatic of the structural static tests. The wingtips are deflected upward until the wing is stressed well beyond the required 150% extreme flight loads that would ever be met. The fuselage of the aircraft is then firmly bolted down. For tests on fatigue, another hangar-bound airframe will be used. Tens of thousands of times have been flown, with the cabin undergoing full pressurization cycles and other components being stressed beyond their breaking point to determine how long they will remain in operation. The Integrated Systems Test and Certification rig by Bombardier for the C Series, which is now the Airbus A220, is an example of a realistic, ground-bound test piece produced by modern aircraft manufacturers. The aircraft's systems, components, including the avionics, flight control, electrical, hydraulic, and even the landing gear, were all exercised during virtual flights by pilots using the ISTCAR, which mimicked all of the aircraft's operations. These supposedly iron birds are connected to engineering simulations that manage the aircraft's internal workings. Before parts are transferred to the final assembly line, component and system vendors conduct comprehensive testing. For instance, Monogram Systems, now Safran Aerosystems, constructed a 3-story tall test rig to mimic the Airbus A380 double-deck Megajet's restroom waste and aviation water systems. Dog food is utilized in place of actual garbage during testing, and it moves through the vacuum waste system at a speed of roughly 135 miles per hour. Before the maiden flight, additional testing must happen after the rollout. The aircraft's engines and auxiliary power unit are started, the fuel tanks are refilled, and leaks are examined. Pilots will next fly the simulated first flight while seated on the ramp and connected to a computer system that makes the plane believe it's in the air, testing the aircraft's systems during a ground-based dress rehearsal. The aircraft is only permitted to move independently if the entire team is pleased with the results of the stationary tests. The final pre-flight test involves the pilot slowly backing out onto the runway, gently testing the brakes, accelerating to just above takeoff speed, lifting the jet's nose, and then slamming on full braking. A modest squadron of aircraft supports the historic accomplishment when the big day for first flight finally arrives. The pilots on the first flight of a new aircraft will undertake fundamental handling checks while aircraft chase the test plane. In order to test systems and assess how the jet flies, the landing gear is not lifted until far into the first flight. The gear doesn't start to rise until they are satisfied. Depending on how things go, first flights might take anywhere from a few minutes to several hours. Each aircraft will be tasked with testing in a different location as more join the fleet. Several hundred hours will be flown to verify the performance of the jet's systems, avionics, and flight controls, altitude, weight and speed, takeoff, landing, and cruise, interior, customer route proving, and ETOPS certification. The latter is the certification that permits aircraft with just 2 engines as opposed to 3 or 4 that were originally the standard for long-haul jets to fly lengthy distances over water or deserts. Sometimes problems arise as the fleet pushes to the edges of the aircraft's performance envelope under unusual circumstances, which can only be fully discovered when the aircraft is being flight tested. To ensure that airframe components don't vibrate at a frequency that can cause severe structural damage, flutter testing is a crucial stage of the procedure. Flutter was responsible for the 4-engine Lockheed Electra's turboprop and propeller catastrophic detachment from the wings in the 1950s. Deliveries of the Boeing 748-8 have more recently been postponed due to small wingtip flutter problems that required to be corrected. New technology in power plants can present its own obstacles to an aviation program. New engine designs sometimes go hand in hand with new aircraft designs. The first high-bypass turbofan to enter commercial service was Pratt & Whitney's JT9D in 1969, aboard a Boeing 747. Boeing tested 40 JT9D engines before deciding on 4 to power the prototype 747 on its history-making first flight since the early engines were prone to surges. More recently, an oil leak caused one of the aircraft's Pratt & Whitney PW1524G geared turbofans to explode during an engine ground run of a Bombardier C-Series test aircraft. Additionally, test pilots noted that the thrust reversers on the initial 737-100s were useless at reducing the speed of the jet while landing, and were instead just producing a lot of noise. As a result, these components had to be modified in the 1960s. Rejected takeoff is one of the most dramatic and hazardous tests. The test aircraft is equipped with worn-out brakes and loaded to its maximum gross weight. The pilot slams on the brakes after reaching takeoff speed to bring the aircraft to a stop as quickly as he can. Only the brakes, which can get very hot from the overuse, can be employed as thrust reversers. The tires will lose air pressure due to the heat, and it could possibly catch fire. The time it might take for an emergency services to arrive during a real RTO is represented by the fact that first responders must wait 5 minutes before putting out the fire. You can see videos of crosswind landing experiments all over the internet, many of which were conducted at Iceland's Keflavik Airport in Reykjavik. The airport's 2 lengthy, nearly perpendicular runways and consistent strong wind make it ideal for crosswind landings. Airports in the Middle East are utilized for hot weather testing, while Buklot in Canada's northern Nunavut region is a popular location for cold weather testing. The test aircraft might also be transported to the U.S. Air Force McKinley's Climatic Laboratory, a climate-controlled hangar that can mimic mimic both extremes of heat and cold. La Paz, Bolivia, at 13,300 feet above sea level, has been used to evaluate an aircraft's performance at high-altitude airports. The Tibetan Plateau in China is a favorite among aircraft manufacturers who must travel to and from the world's highest airports. And the exams never stop. To test whether the new plane is compatible with airport infrastructure, places around the world are visited as well as simulated long-distance airline flights with full passenger loads. The aircraft is hauled on its tail into the air at its slowest possible pace, scraping along the runway. To prevent water from entering the aircraft's systems, the aircraft will even plow through a sizable puddle. A type certificate is then issued, signifying that the design of the aircraft is safe and airworthy. When the test program has been completed to the satisfaction of the aviation authorities such as the FAA, EASA, or Transport Canada, the airframer will subsequently be given a production certificate, allowing it to continue producing the new aircraft following a thorough assessment of the manufacturing process by the regulator. Each new airplane goes through production and customer flight testing before receiving an airworthiness certificate that is specific to each new jet, as it leaves the assembly line and is headed for an airline or business customer. Only now, it can take paid passengers at that point. That's it for today. Hope you liked the video. Share it if you did. Like and comment on the video that you want to see next on our channel, and subscribe to see our future videos. We'll see you in the next video. Till then, keep watching.